As I said, on the old test, you would have had to actually draw a slope field. On the test now that is going to be the hybrid test where you look at it on the computer, I don't think they're going to ask you to draw a slope field based on the things that we've been told, because they say that the answer sheet is just blank space. So they used to give you like a slope field and it had dots and you had to draw a slope in it, all the dots that they gave you. I don't think they're going to ask that anymore. So what you're more likely to see is questions like this here. So it gives us, for this one, slope field for a certain differential equation is shown above. Which of the following statements about a solution to the differential equation must be false? Yes. There we go. So it begins with the graph of the particular solution that satisfies f of -3, 2 is concave up on the interval. So if there are two things they can ask you about from a slope field picture, they might ask you about the solutions, or they might ask you about what the differential equation would be. So everybody up here, please. All right, so the solution should have to fit the flow of the diagram. The solution will be an equation that would be graphed. It'll be a line, and it should fit the flow of the diagram. If they ask you about the differential equation, you are looking at each of the little individual slopes. So in this one, they're asking us about the solution. And when they say that it satisfies f of -3 equals 2, that's giving you a point. So it's telling you the graph goes through -3, 2. And so -3, 2 is this point right here. And if I want to draw a solution that goes through that point, this may not be perfect, but I could draw in some sort of graph that would look maybe something like this. This like dashed line right here, that's going to sort of serve as like a slant asymptote here. Now it might not look exactly like that, but it should go with the flow of the graph. What you cannot do, like what I would not be able to do, is I cannot like make this go back down right here where it starts to go across those lines, right? This would definitely not happen for this graph. So all of these dotted lines right here, I can kind of tell this is an asymptote right here because it sort of forms a line you cannot cross there. So this graph is concave up. It appears that A is true. But let's look at the other ones to see if they are true or why they would not be true. So for B, this is the point -2, -2. So -2, -2 is right here. And this tells us that we have a relative minimum. I'm sorry. A is not the answer, because what does this question ask us to find? If it's false. So A appears to be true, so it is not the answer. And so here it says a minimum, and right there around -2, I've got a horizontal slope, right? So that would imply there that this graph should do something like this, and I would in fact have a horizontal asymptote there. That's going to be a minimum point. So it appears that that is also true. For C, we got 0, -2. So 0, -2 is this point right here. And if I kind of draw in a graph here that fits the flow of this graph, it would look something like this. And it says that that is concave up. Is that graph concave up? It is not. So I think this one's going to be our answer. That looks like it is a false statement, but let's look at D. The graph of a particular solution that satisfies f of 1 equals 0. So that's the point 1, 0. 1, 0 is right here. It's on that dotted line that sort of serves as an asymptote, so it would be the only place where you are just going to have a linear graph, so that one's also true. So C would be the one that's false there. Okay, questions? Okay. 4 is another one that asks us about the solution. So the slope field for a certain differential equation is shown above. Which of the following could be the particular solution to the differential equation satisfying y of 0 equals 0? It's giving you a point right here. That's the point 0, 0. And so 0, 0 is right here. And if we sort of draw in a solution to this, we would get something like this, and it's going to have a horizontal asymptote there. So I need to know which ones of these would, or which ones are possibilities here. So which ones could you throw out? Okay, it's definitely not a sine graph. You don't have like anything that looks like a sine wave. What else do you think we could throw out? Okay, it's not going to be A. I mean, it is going to be a quadratic, like a quadratic. This could be like a piece of a quadratic maybe, but I don't see it going back up. If you look at that quadratic, if you factor it, you'd have x times x minus 1. You would have zeros at x equals 0 and x equals 1. So that would be here and here. So if you have zeros right there, that would mean it has to like turn back up, right? So it's not going to be that one either. Yes?
I can't remember if this is exactly right, but in pre-calc, is the square or the even exponents, does that mean that it like touches the x-axis and goes back up?
It does whenever it's factored. Okay, so if it was like x squared times something, then it would mean it touches the x-axis and goes back up. This is not factored. Your factored form would be x times x minus 1. So, but you could think about like your zeros, which are going to be the places where you cross the x-axis. So you should have a 0 at 0, 0, and at 1, 0. So if the quadratic was the answer, you would have to go through those 2 points. And to do that, you'd have to go back up right here, which would cut across your graph. So, so that one won't work. So that leaves us with C and D. And C and D are not ones that we know a lot about, right? I mean, we know about exponentials, but not with all those negative exponents and all of that crazy stuff. So whenever we think about this, both of them do have a minus 1 on the end. And that sort of like shows you that it's been shifted down 1. Exponentials do have horizontal asymptotes, so we see that horizontal asymptote showing up there at 1. It does not help us distinguish between C and D, really, because they both have that minus 1. So let's think about what kind of numbers we would get if we plugged numbers into this. So the first point you can try is the point 0, 0, because it needs to be on both of these graphs, right? So if I do e to the negative 0 minus 1, that's just e to the 0, which is 1 minus 1, which gives you 0, so that works. And then I've got e to the negative 0 squared minus 1, and that's 1 minus 1, which is 0, so that works. So you want to test it just to make sure it's not like the thing that you can see, but it doesn't help us here because it works for both equations. So what I would think about next for this is what happens at the, what happens to the values as you plug numbers in. Negative exponents are difficult to think about, so I would write this one as 1 over e to the x minus 1. Okay, and that would mean that d would be 1 over e to the x squared minus 1. So, now, large numbers are not going to help you here. What's going to happen as the numbers get bigger and bigger and bigger for this function? The bottom of this fraction will grow, which means that this part's going to get closer and closer to 0, and you'll just get negative 1, right? So what we're looking at is like a horizontal asymptote at negative 1, which we see happening. Would it be any different for D? It will not. The key that's going to help you on this is thinking about plugging in negative numbers, okay? Because if I plug in a negative number, like if I plug in negative 1 into this, or I could think about plugging in negative 1 into the original, e to the negative 1 minus 1 is going to give me e to the first power minus 1. Okay, so that is like 2.718 minus 1. I get like 1.718. So at negative 1, I should get like 1.718. This seems like it might work, right? But if I plug in here e to the negative 1 squared minus 1, then I would square this, which would give me e to the negative 1. Right? I'm going to square that negative 1, which will make it positive, but the other negative is still out there out front, minus 1. And so that's going to be 1 over e minus 1. And I don't know the decimal for 1 over 2.718, but I do know that it's less than 1, right? Because e is 2 point something here. So I'm going to get some negative decimal, like negative point something here. I'm not sure what, but a negative decimal of that. So at this point, negative 1, negative something is not happening for this solution. So that is what would finally rule out D, and then C would be our answer choice for this. Sometimes these questions are really easy because they might give you this question and they might give you options like sine, quadratic, a natural log, or something that it can't be, and then it gives you the one that actually works. Sometimes they give you stuff like this where you really have to think pretty hard about. You usually can rule out a couple first, but you have to think pretty hard about those solutions.
So why is that the right answer? Is that like this slow? I don't get why that one's the right answer.
So for these, I have drawn in this solution. It may not be perfect, but it should be close, right? So if I plug in numbers to this equation, those numbers should be at least close to being on this point right here. So like when I plug in 0 for both of these, I get 0. So they both go through that point right there. But when I plug in negative 1, I'm getting that, like for when I plug in negative 1, I'm getting like 1.78, and negative 1, 1.78. That's pretty close to being on my blue line that I drew in there. But whenever I plug in negative 1 to the one that has a square, I get, I don't know what it is exactly, but I have some negative number, and that's not on the graph. Does that make sense? Yeah. Okay, questions? And like plugging in positive numbers is good to do, but it doesn't help you very much here because you can't really tell the difference between 1 over e squared minus 1 and 1 over e to the 4th minus 1. They're going to look so close together, it's not going to help you for that. Okay. Let's see. I really need another one. I might do one from the homework. Let's see what they. Okay. We're going to do this one. This is what it used to look like on the exam when you had to draw the slope field. So this is a like a question that they used to give on the exam, free response question. You won't have to do part A anymore, but I think part A is maybe like somewhat helpful for being able to do part B. They definitely might still ask you the part B of this. So they have given the differential equation 2 minus y over x. So we just have to sketch this, and you used to have to do this there. So you could make yourself a table here. So, and you've got 9 different points. So you've got like 1, 1, 1, 2, 1, 3, and then you've got 2, 1, 2, 2, 2, 3, and you got 3, 1, 3, 2, 3, 3. If you'd rather just do it by looking at it, you can, but the table is sort of a surefire way to make sure you get it right. So, like when I'm finding dy dx, I'm doing 2 minus my y value, which is 1 here, over 1, and that gives me 1. So at the point 1, 1, I have a slope of 1. So I draw in a little section of line that has a slope of 1. And then I would do 2 minus 2 over 1 for this next one. That's going to give me 0. So a 0 slope is what kind of line? Flat horizontal, right? So horizontal line right here. Oh, no, what am I doing? Wrong spot. That is at the point 1, 2. 1, 2 is right here. Now, where else am I going to get 0? Along that whole row. Anytime the y value is 2, right? So here, because when I do, here I'd have 2 minus 2 over 2. That's going to give me 0. Here I'm going to get 2 minus 2 over 3. That'll still give me 0. So sometimes I skip around a little bit when I notice those things. If I've got 1, 3, that is 2 minus 3 over 1. And that will give me negative 1. So I have a slope of negative 1 right here. And then I'm going to do the other point. So I've got the point 2, 1 will be 2 minus 1 over 2. And that will give me 1/2. So this line right here should be less steep than the one to the left of it. And then I'll have 2 minus 3 over 2. That's going to give me negative 1/2. And so that would be at this point, and it would look like that, not quite as steep as the one before it. And for the last two that we've got here, we got 2 minus 1 over 3, which gives me 1/3. So this point, again, a little less steep than the one before. It gets hard to tell the difference, but as long as you're not making like blatant errors, like that one's clearly steeper, you'll be okay. And then 2 minus 3 over 3 is going to give me negative 1/3. And so that would be this line here. Okay, questions there? All right, so then the second part is still a part that they would certainly give you. So it says, let f be the particular solution to the given differential equation with the initial condition f of 3 equals 1. Write an equation for the tangent line to the graph of y equals f of x at x equals 3, and then we're going to use that to approximate f of 3.5. So it's a tangent line to the graph of y equals f of x. So we're thinking about the solution that goes through the point. They're giving us the point 3, 1 here. That's our point. And so you're not required to do this, but 3, 1, we're talking about this point right here. What is my slope at 3? It is 1/3. I could pull that from my table right here. To write it over here, I would say dy dx such that xy equals 3, 1 is going to be positive 1/3. You don't necessarily have to show the work since you've done it earlier, but do label it so you have that there. This is your slope. So your tangent line will be y equals 1/3 x minus 3 plus 1. That's a little bit of a good review, given that we've got midterm coming up, because that's some stuff we've done a long time ago that we were pretty good at. We were pretty good at tangent lines at one point in time. There. Are we done? You got to plug in 3.5. So free response, I mean, really, this is what I would do. F of 3.5, squiggly equal sign, 1/3, 3.5. Oh, sorry. Don't close that parentheses yet. That'll mess you up. Minus 3 plus 1. And I would stop there because it's a free response question. But, of course, you could simplify it if you want. Okay, questions? I do want us to do, let me give you, let me give you the worksheet. It'll be the assignment for this. I want us to do one more type of question that I did put on here. Maybe copies for me, and I'm not sure what this is. Okay. Let's look at that worksheet. And this is right here. Okay. I want us to go down here. All right. And let's do like number 2. I'm going to screenshot this so I can write on it. Right here. Okay. This one asks you to match the slope field to the differential equation, not to the, like, these are not the solutions, they are the differential equation. Some of these differential equations, we know how to find the solution for them. Some of them we do not. Okay? We can only find a differential, a solution right now if we can integrate it. Right? So, which ones of these do we know how to integrate? We know how to integrate 7, right? Because it just has one variable there. And we know how to do 10. We do not know how to do 8. We could do 9, but we would get an answer that's like in terms of y, and that would not be very helpful to us on knowing what the shape of the graph looks like. So, like, if we integrated here, if we could put the dx over here and integrated, our solution would be, when we integrate cosine, what do we get? Integrate sine, what do we get? Negative cosine of x plus c, right there. So we're looking at a solution that would be a cosine graph. Which one does that look like it goes with? That looks like it's C, right there, for that one. Okay. We could do the same thing over here. Put your dx over on this side, and we would get y equals, what do we get when we integrate x? 1/2 x squared plus c, right? And what type of graph is that? Quadratic, parabola. Which one of these graphs looks like it could be a parabola? B. So B would be our best answer for that. Now, we do not know how to integrate 8 or 9. We'll learn how to do number 9. We will not even learn how to do number 10. It's not a separable differential equation. But we could still match the slope field. So if we're thinking about matching slope field here, we're thinking about like what kind of slope we would get when we plug numbers into that differential equation. So we're down to A and D, right? One thing that can be helpful is thinking about where your slope is going to be 0 because they're really easy to pick out. For this function right here, when is your slope going to be 0? 2, 2 would be an example. Where else? Anytime x and y are the same, which graph looks like it has that characteristic? D, right here. So D would go down here. And you can check other points on the graph. This is not like really labeled where we know it's like 1, 2 or 2, 1. Like we don't really know. But like if I have like 0, 1 and 0, 2 and 0, 3. 0, 1 is going to be negative 1. 0, 2 would be negative 2. 0, 3 would be negative 3. And we see that pattern like, oh yeah, the slopes are getting steeper as we go up there. So that seems to match. So we're thinking about like what our individual little lines look like instead of our solution for that one because we don't really know what the solution is. So that would obviously leave us with A for number 9. One of the key things for number 9 is it only has y's in its equation. So anytime the y value is a certain value, you'll get a whole line of slopes that'll be the same. So if you look at this one, like right here, your slope is going to be 0 at y equals 2. So that whole line is the same. All you have those 0 slopes, right? Then at 1, you have a whole line of slopes of negative 1. And then so on from that. So that can be like a key to help you match. So whenever you can think about the solution, you're thinking about what would like fit the flow of the graph. But when you can't think about the solution, you have to think about like kind of like doing these by hand, like you're making the table and plugging it in, make the table, plug it in, see if it matches what you would have for that. Does that make sense? Okay, we're going to take about 15 minutes or so to let you get started on this. I am not going to have, let's see. I'm not going to have you guys do the slope fields on the front yet because we don't have to do them by hand this year. So I think the most important thing is going to be that you can answer these questions that come after this. Whenever you get to 17, you cannot do C, D, or E on that. So you can mark those out for now. You cannot do C, D, or E. And on 18, you cannot do C. You could still do D. Like you can still sketch that particular solution even if you don't know what it is. Okay, and you can't do E either for that. So, so let's take a few minutes and